Today I will introduce Egear function of our AC60. So here is our today's content. I will introduce define of Egear and some related function block and use one case project to show how to use the function block. First part is the define. In short words, I think this Egear function is used to realize some gear transmission functions through the software to simulate the movement of the machine code gears. This is the define of the gear, electric gears. Compared with the machine code gears, here have some advantage about gear. First, we can freely to set the speed ratio between the master and the slave without changing the hardware. And also the gear ratio is supports dynamic modify. And then last, we can use gear imports. We can use this function block to copy to make our master and slave to enter the sync status and specific positions. And also, I think gear is free, but if you want to make a machine code gears, it's very needs cost on hardware. And now I will introduce some related function block of the gear function. First of all, let's show the prepare part. First, created the project here today. In today's demo, I use this CFC language. And in this devices, we right-click this soft motion general axis port to add device and select to virtual drivers to edit. And here I name this to axis as master and slave. And in this CFC programming language, we can draw a box from this toolbox to our programming page, and also input or output parameter. Enter the name of the motion function block. And we can use the mouse to connect the input parameter to this input. Here I directly enable the drivers after we run the project. So we set the terminal of this enable or set line as true status. And you can continue to add other function block using the same way. Draw the box from here and enter the motion function block name and connect input or output to the input or output. Okay, and now I will introduce this parameter, this function block one by one. First is this MC gear in. This function block is used to make our slave running according to the master with the setting speed ratio. This is the usage of this function block. For example, this is the ratio. For example, the master speed is 10, and we trigger this function block. The slave, and also for example we set the ratio as 1, and after we trigger this function block, the slave will begin to speed up with this acceleration we setting here, and continue to speed up until the slave speed is same with the master speed. Then the slave will enter in-gear status, and for the following movement, the speed of the slave will real-time changing according to the speed ratio, and the master speed. And another function block is MC gear impulse. The difference between these two function block is after we trigger this MC gear impulse, here have some position input parameter, master sync position, slave sync position, and master start distance. How to understand these three parameter? Step 1, when the master achieve this value. For example, here if you set the master sync position as 200 and set the master start distance, for example, as 100. So with this setting, when the master achieve position 100, the slave will begin to catch up from its current position, and also this start sync flag will turn on. And during this time, the master will continue to going forward, for example. And when the master reach this master sync position, here is 200. When the master achieve 200, the slave will also reach this slave sync position. For example, you can set it as 100, 200, or 300. If you want the master and the slave enter this sync status in same position, then you can set the slave sync position as 200. Same with the master sync position. So after step 2, the master and the slave will enter in sync status. This start sync flag will turn off, and this in sync will turn on. And for the following movement, it will be same with the gear in. So how did the slave adjust its speed during this during catch up time? The PLC will calculate the time of the master. For example, the current position of master is 150, and then the master sync position is 200. Here we will get the error 50. And for example, the current speed of the master is 25. Then we will see after 2 seconds. After 2 seconds, the master will achieve the master sync position. So with this time, and also we can get the current position of the slave. For example, the current position of slave is 50, and our slave sync position is 200. So it means the slave need to uh, move from 50 to 200 within 2 seconds. So here we can get the speed of the slave is for example is uh, 75 unit per second. So this is how the how this function block calculate the speed of the slave, and with this value changing, the time will changing, and also the distance between slave position and the slave sync position changing, and also this speed changing. So this is a dynamic modified to a dynamic adjustment of the slave speed. Okay, let's continue. Wait a moment. Okay. And some other function block, for example, MC gear out and MC stop. Gear out is used to, after gear out, the slave will keep its current velocity and continue running. If you want to stop the slave, you can use MC stop to stop it. So it means after gear out, the slave will not stop directly. We need to use MC stop to stop it. And some other function block is move velocity. I use this function block to move our master axis with a fixed velocity, and use this MC home to reset the system. And you can also create some, for example, MC reset to your project to clean the error. And next is created. Here I created a visualization to view the movement of the master and the slave. And the step is I have already introduced this part in our last training. Here you can put to motto. You can search driver and put this to your project, and bind the axis to this object. Here, input axis refer. And also you can enter the function block name to add this function block to this visualization. Okay, so here I created this to the project. And now I will use the test project to show you the usage of this function block. First is gear in. We can check the project again. This is the what? This is the demo project. Two MC power to enable the driver, and one gear in, one gear in pause, and gear out, two MC stop, to MC home, and also use this move velocity to move our master. And also here created a custom function block to simulate the flying cutting. Okay, so here the speed ratio is 1, and the acceleration deceleration is 10. Here after we trigger this MC gear in, you can see the status. I can continue. And now we begin to move our master. And you can see the slave is following the master with the speed, and we change the speed ratio and trigger this function block again. Now the slave is begin to speed up, but this in gear is off status because the speed of the slave still haven't still not achieved 5 times of the master. Now change the ratio to 0.2, and the slave begin to slow down according to this deceleration. And here, when the speed of the slave achieve this 1.15, how to say 0.2 20%. When the slave or the speed of the slave achieve 20% of the master, this in gear flag will turn on. So they are in gear status now. So here at the beginning, when I trigger this function block, you can see this in gear status directly turn on because the initial speed of master and slave is both are 0. So after we trigger it directly in gear status. So this is the usage of the gear in. And next, I will introduce the usage of the gear in pause through this video. Here with the initial setting, I set the master sync position and the slave sync position both are 200, and set the master start distance as 150. And the ratio after gear in, after in sync status is 1.1. It's 1.1, so the master and slave will keep same speed. Okay, we can directly run the function block. Okay, now this function block is in busy status, and we begin to move our master. Okay, here you can see master begin to move, but the slave will keep its position because the master still didn't achieve the sync start distance. Here the start distance is 50. 200 reduce 200 reduce 150 is 50. So when the master achieve 50 here, and then the slave will begin to catch up. And when the master and the slave both achieve 200, this master, you can see this in sync flag will turn on. So the following the following movement, the slave and the master will have the same speed because here we set the radio as 1. So this is the usage of the MC gear imports. The only difference is here they have one catch up segment. uh, do we have to install any code for that? Or is what do you mean? You mean this visualization or something else? All the project you see is built in Cortex. The only but you need to if you are use Cortex software, you need to import the device description file of AC60 to your PLC to your software, and other part is all built in Cortex function block and this visualization. Okay, so this is the usage of the gearing. Do you have any questions? You can type here. If no questions, I will continue to show the last part, how to use this gear in post function block to do the flying cut application. Can you give these examples for AC60 controller? Yes, I will send these examples to our training group with the presentation. And here I use LX60, and if you are using AC60, you can here just right click this device, right click to update device to your PLC here. Okay, now the last part, let's check this. For today's content, all models are support because it's just MC control. D0, but no, I'm not use web virtual. It's just a visualization function, not web virtual. But if you want to use web virtual, you need DC or DD type, DC or DD model. Yes, for this function, all model are support. You can also use this for DA. Okay, here let's check this cut this function block. Here if after we click start input of this custom function block, we will first to check the position of the master. And here I use this condition. When the master position is bigger than 0, then we trigger this gear impulse. And in real application, here maybe you can use the input signal of the some max sensors or something else to as the start signal. And here after gear impulse, after Egear impose and the master slave internal in sync status and the position of the master is bigger than 250. We enter these steps. In these steps, the slave will gear out and stop. After the slave gear out and stop, we will use one move absolute function block to make our slave go to the home position. And at last, we go back to status 0 to wait the next start signal. And other steps are sent to realize the cyclic control. So it will be like this. We stop it. Here, all this signal are from this function block, geo impulse, move absolute, and so on. And we click this start to, and the next we begin to move our master. For example, with speed 20. And here you can see when the master achieve 50, the slave will begin to catch up. It's too slow. We can speed up the master. And when the next start signal coming, the slave will begin to catch up and now cutting and stop and go back and wait for next start signal. And we can continue to speed up the master. But here we need to calculate the do some calculate because we need to make sure the master have enough time to go back to sorry, we need to ensure the cutter axis have enough time to go back to the home position. For example, if the how to say, if the master speed is too quick, like this, you will see in some cycle the slave can't start because before it turn back to 0, the next start signal is coming. So here the speed of master is too fast. And also we need to make sure the movement will not make the motor report some error, for example, or lot or something else. AC60D0 also support this, but you need to use post control because D0 don't have because D0 can't control the Ethercat axis, but you can use post axis to do this and set the input axis as the encoder axis and output axis as the post axis. The master is just from the motor servo, or we can yes, we can use encoder axis here. High speed I/O. counter. You can use this in the axis NAND encoder. This application is usually used uh, for some cutting like this. Let me check. Uh, it's used for some application like this. The slave from the zero position and catch up the master, keep same speed, cutting and go back. The difference between MC gear impulse and MC gear in is here for MC gear impulse. Uh, MC gear impulse can make the master and the slave to enter the gear status and a position where we setting. For example, you want when the master achieve 200, uh, the slave will also achieve, for example, 100 or 500 at the same time, and then it leads to internal joining status. So they have some position. Position also have some position control in MC gear impulse. But for MC gear in, it have nothing to do with the position. It just control the speed of the slave to achieve the setting ratio speed of the master. How to think for suppose if I have an encoder for flying gauge. For example, but it's let me think. Uh, you can uh, you can clean the master position when the PLC receive the start signal. So every time when the yes, you can reset. You can clean the position of the encoder position when it achieve the start signal. Okay, let's continue. This is our today's content, and our uh, our next training will be next Tuesday about, and I will introduce ECAM function in yes next Tuesday, and welcome to join